Awesome. Yeah, and for folks joining in, I mean, maybe just to set a little bit of context, I mean, building agents is and you know, building agents has probably become one of the hottest topics that um, we work with our own users and with our own product experience. Um, and there's a lot that goes into it. So today, a little bit of what we're going to be covering is first, um, this entire series is about showing different, you know, agent applications in the wild. So we're going to start off with actually showing our Copilot application. We're going to talk about what it does, and then we're going to jump into the architecture and talk about different um, components of how this agent was built. Um, and then we're going to jump into actually a real example of how we iteratively improve our agent. So we'll walk through the workflow of everything from how we think about evaluating it, how we think about you know, figuring out where to drive improvements. So we'll jump into all of that in this session. Cool. Let's jump in.
Yeah. Cool. Do you want to do a round of intros first, Brenda, before we jump into it? You want to start us off?
Awesome. And yeah, that's a great idea. My name is Aparna. I'm one of the founders here to Rise, I run product, and yeah, technical background similar to Sally.
Yeah. And hey, everyone, I'm a product manager, work with Aparna here. Similar background, like she said, and super excited to be here. I'm actually the product manager that leads a lot of the Copilot work. So happy to be able to join y'all and share what we do there. So with that, our agenda.
Awesome. So like we said, this series is about highlighting different agents in the wild. So you'll hear about, um, some of our own, you'll hear about some of our users, and our goal is to spotlight them. So this one's where we're going to be talking about the Arise Copilot. We're going to deep dive into a specific skill within our agent, and then we're going to talk about how we built it, the architecture of it, and a unique kind of workflow for how we actually improve our own agent. But first off, okay, jumping into what is Copilot. So the Arise Copilot is, I like to think about it as AI to help you build AI. It really is a integrated kind of product experience to help you use AI to actually improve your applications. So things that Copilot does is you can talk to it using a chat. It's also embedded directly into the product, but it helps you do optimize your prompts. It helps you build your own evaluations. It helps you curate data using things like AI search to actually find the right data to improve your application. So every part of the workflow of how you iteratively improve your application or iteratively kind of experiment, or even once you're in production and you've deployed the application, trying to do that root cause analysis. There's all sorts of skills that are embedded into the product to actually help you analyze a little smarter with AI. Anything else you want to add there, Sally?
I think you hit on all of them. I think the next slide, I just kind of previewed it. We'll go through all of the skills, but yeah, it's AI assistant to observe AI. We built a lot of the workflows that you would kind of think of when you think of either, ML or LLM workflows into Copilot to help you do all of those. And I think that's probably a good segue into our list of skills here.
Yeah. And the way that users use this is, as they're using our own product, I mean, think about us, we're a product that helps AI engineers actually troubleshoot their AI applications. Um, we're really Copilot's really like this assistant that they have throughout that experience. So if they're in the product and the application's already deployed into production, Copilot tells you what to go look at, what evals to go set up, where there might be insights into your application. Once the user actually finds those insights or finds out what's wrong, they can pull that data back into a development kind of workflow. And Copilot can help with that too. Copilot helps you curate that data and then tells you, hey, here's how you could optimize your prompt. Here's how you could build an eval to actually test that experiment. And so every single part of this workflow, there's skills so that the AI engineer kind of has this kind of buddy to help build their application with. And today what we're going to do is actually deep dive into one specific skill and walk through kind of how we built it and how we improve it. But before we do that, let's jump into a little bit of the architecture so you can see how we built this. You want to jump in, Sally?
Yeah. So this is kind of a very high level overview of Copilot's architecture. So again, it is like this agent structure. So we're gonna have a user question. And then what's kind of unique about our setup here is we actually have a bunch of different routers. So depending on where you're entering the platform or what kind of skills you're working on, there's a different router there to help you. And each router has a set of skills there to help it. So we have like a tabular router. This is for our traditional ML use cases, things like getting performance insights, looking at drift, looking at data quality. Those are all the skills that live under that router. Then we have specialized routers like the prompt optimization router or the search router or the eval router. Those might only have, one or two skills under them with very specific tasks associated with them. And then, we have our LLM router, very similar to tabular, where it's more like generalizable skills for LLM use cases. And so how it works is, a user question is going to come in and it's going to get, pushed to a particular router. So if we follow this line here, we're going to send something to the tabular router. The router is going to take that user question, maybe some additional metadata, and then it's going to choose what skill would be best to actually answer the user's question. So if a user said something like, can you find me an insight? It's going to call that performance insight skill. And then another thing that's unique is we have chosen this graph approach. So each router can call a skill, and that skill is actually what gives a response back to the user. So there's some different types of router kind of architectures. There's things like hub and spoke where, there's a router that's picking different skills, and then that skill actually goes back to the router to respond. We've actually chosen to go ahead and have the skill respond directly to the user. So that's another little unique piece of our architecture. And we can also set up, it's not really shown here, but we also have it set up so each skill can also act as a router. So if there's a chain of skills that we want to chain together, we actually have some skills that we're working on that follow that architecture, but you could have a router that calls a skill and then a skill that calls, an additional skill after that and so on. So you can really chain these types of functions together, which is pretty cool.
Yeah, and I think maybe one of the this one's interesting. There's a lot of different agent architectures out there. You might be familiar with some of them where, like Sally was saying, where you have to go back to the router to actually respond to the user. There's some where the the routers can call each other. Like in Sally's example, the skills can then go back and call other routers. Um, Maybe one thing worth highlighting for us is why do we have like we could have built this in one way where it was all just a single router and the single router had access to 30 plus skills.
Yeah.
And instead, what we've actually done is broken this up into five or so different routers, and each of them are have focused on a certain set of skills. Why did we do that? Like, what was the pros cons of that?
Yeah, really good question. I think definitely one of the pros is kind of just like keeping it specialized to specific parts in our platform. Like when we get into the demo, when I show you, you're going to see that the search router is actually tied to, our traces page in your filter experience. So there's a kind of a software engineering kind of aspect to that. And I apologize for the noise if anybody can hear it. My dad is having a bad day today. There's specific components. So the software engineering side of things just made it easier, but then there's also just the performance that we found. So in the beginning, we had one router with a bunch of skills associated with it. And as we added more and more skills and Copilot was tasked with more and more things, that slowly became impractical. We saw it struggling to pick from, 30 different skills. And so that was another reason we decided to kind of split up the routers and have very specialized ones. So it's partially just because of like the experience in our software platform. And then the other part of it is just on the LLM, making sure that it's performant and choosing the skills appropriately.
Yeah, I mean, I think this one's actually a pretty important one because um, you're almost what we're doing is we want it to call the right skill. Like ultimately, that's one of the things that if it goes and the user asks a question about performance insights, but then it calls something about summarizing evals, let's say, like that was the wrong skill to call. You're just going to give a bad response back to the user, and it's a bad product experience. And so in I think one of the advantages of breaking it up so that there's multiple routers that are specialized is that you limit the surface area of skills that it has to choose between. So instead of having to choose one out of 30, you're kind of choosing between one out of potentially three or five. And so you're giving it better odds to get the right skill and pick the right skill. And that's we're calling it skill. I think what you all will, the term that you'll, parallel term you hear is just calling the right function. And so making sure that you know, you're actually doing that is probably the biggest indicator of whether or not you're going to give the right user experience in our case.
Yeah. And I think like well, as we talk and go through AI search in our iterative process there, you can also see us kind of apply that same logic to building different skills and how we choose to do that. So I think making sure you limit the LLMs like surface area is definitely something we found to be very helpful.
Um, okay, we have a question from Blake.
Okay.
Interesting about routers versus agents. Why isn't router a subtype of agent? On another hand, it sounds like a cluster manager. Um, and so, okay, so it's a good question actually. So I think that there's kind of there's five or so different routers that we have in our system. One thing to note, I guess, on our specific um, agent, I guess overall agent here, is that the router is actually kind of pre-picked based off of the incoming kind of product location that someone's coming in from. So if they're coming in from, like Sally was saying, the toolbar, the search toolbar, if they're coming in from this prompt workflow that we have, there's kind of this pre setup of what router is actually being, um, what router they should be directed to. But in some cases, I mean, we've talked about this before, Sally, is like there could be a decision of what router to even go to. And so that could be kind of like your, I don't know, your mega router or whatever, like your router that picks the router to go into. What would you have to consider if we were going to go down the path of the mega router?
Yeah, and it's something that we actually, as we continue to build more skills and we kind of think about the experience overall, it's something that we do consider. And I think what it is our with our current setup, it's kind of like one of those things, if it's not broken, don't fix it type of thing. Like this setup works, of like keeping it separate works. I see another question of like, why not have like this like mega router, pick which router? It seems a little unnecessary. It feels like a little bit of an extra LLM call that we don't need. Now, as I look at our LLM router or our tabular router here, we're adding more and more skills under those routers. And so it's starting to feel like, okay, maybe that needs to be a mega router with some like more specialized routers in between. Maybe we have a performance-based one. Maybe we have one that's more support-based where we have like support type skills under there. Maybe there's an actual like actions-based one. Think of something where, I'm having an input and asking Copilot to do something like create a monitor, create a task. So as we start to add more skills, I think we're starting to think, okay, where would be the appropriate place to make sure that we can maintain the performance, maintain that Copilot's going to choose the right skill, but also not add unnecessary complexity, unnecessary latency, unnecessary cost. And so I think that's what we're kind of thinking about now, is like that balance. At the end of the day, this is a customer facing application. That's our customer experience is another thing that's always going to be top of mind for us. And so that again, I think ties back to those same things, like can it perform well, but also not add too much latency. And then we don't want to, of course, acquire cost. So that's kind of the trade-offs and what we're considering
Yeah.
right now.
Yep. And I think again it comes back down to like what are the design principles that is important for your application. One is for us, we wanted to make sure it picked the right skill. There was opportunities for us to narrow down um, by preemptively going down to a router that then picked across certain subset of function calls. That was an important decision principle for us. The second one is we wanted the ability for each of the skills to then be able to have the opportunity to go back and call another skill. So each of those skills can then, like Sally was saying, go back and point to, okay, well, they asked a question about, summarizing, let's say, evals on their application, and now they want to jump into, well, how do I make the prompt better if I'm trying to optimize for this eval? And so that's another architecture decision was, do we want, how do we want the chain to grow? Is the end of each chain going to just be a response back to the user, or can we also trigger other skills can it do both? And I think that's kind of one other kind of decision point. The other one, which is, well, each of the skills we wanted to be able to have the ability to not go back to the router in order to make a response. And so there's all these decision trade-offs that are made based off of what we were trying to optimize in this application. And I think that as you start to see some of the other ones we do in this series, you'll see that some people want a specific router to go through to clean up the response. And that's kind of like a central point that they do before they actually pass it back onto the response. And so there's a full, I think, decision trade-offs that each agent architecture that people are building, you're going to have to think of what makes sense for your application.
Totally. And we have some questions in here I do want to clarify.
Yeah.
So there's some questions about the router of, I think I want to be clear, all these routers are LLM routers. Each of these is a router. It gets a set of tools. We're using Azure OpenAI, sending tool calls with chat completions. Each of those is a router. There's just not a mega router that is picking a router. So I just want to clarify, these are LLM routers. They're not like code-based routers. And there's another question of reusing a framework. We've actually decided to go with a custom framework. We actually have a few previous webinars that we've done that we dive into different frameworks and why we've chosen to go ahead and build our own. So I definitely recommend checking that up if you're curious of why we don't have a framework. But I just wanted to answer some of those clarifying questions before we move on.
Awesome. Yeah. One more on the agent frameworks. I think there's actually a blog post we'll link in here where we've actually done a comparison of some of the agent frameworks out there and then kind of our own build it your own kind of approach. Ultimately, the build it your own is what we went down, and it was because of flexibility. We wanted to have the full flexibility of kind of everything from what are the nodes and the edges or the next steps that the skills can call. I think there's just so much more flexibility we could have by building it on our own.
And it's in the blog post that Sarah just dropped too, is when we actually started building Copilot, a lot of those frameworks were not also very thought out. Like it was very new. There weren't all these frameworks that we're seeing today with this kind of growing popularity of the agent workflow. And so that was another thing I always like to call out is like the world today is not the same world that it was 6 months ago, or actually 9 months ago now when we first started building Copilot.
Yeah. Cool. Okay, we could spend probably the whole webinar on this and other agent architectures. So I'm going to put a pin in this for a second and jump into, I think, an equally interesting next step, which is, well, once you figure out what you want most people are probably going to start from high level. You start off by maybe building a rough, okay, here's a user question, and then here's a series of skills that your agent's going to call. I mean, I think that's going to be probably pretty standard across a lot of these applications. And so what we're going to do is actually dive into one specific skill in our agent, and then talk about how we actually built that skill. And I think we'll run you through the workflow, run you through what the decision trade-offs we needed to make were. So with that, AI search, I guess, Sally, do you want to maybe first demo AI search just to show what it is?
Yeah, absolutely. So if you go into our platform today for any of our generative model types and you come into our filter bar, we have this filter with AI section. And so this is where AI search lives. It's supposed to be a tool that helps you filter, curate your data for various applications. And we'll get in all to that in just a little while, just giving you kind of the elevator pitch here. And so what's really cool is you can use natural language to actually search and I'm going to show you the skill that we initially started with. Now, it's a little bit of the story today, which is a semantic search over one column of data. So I could say, find frustrated user inputs. Actually, you know what? I'm going to say find inputs that mention ingestion, make it a little bit more specific and but also vague where I'm not looking for a specific keyword. So what Copilot's going to do is it's going to grab that inputs column and we're going to give that into a prompt with some instructions that say, hey, I want you to find this user criteria. And Copilot's going to look over all of that data that we've sent it and then, provide this response. So off the bat, it says, okay, I'm searching for inputs that mention ingestion in this column input.value. I found 6 fans that match that criteria. Here's a little bit of a summary and here's some examples. So what's really cool is now you can just filter for these matching spans. We're going to grab all of those matching. You can see here, those are the 6 that Copilot mentioned it found. And now you have it as a filter. You can interact with this with additional filters. If I just wanted to see something like the, span kind here, maybe I just want to look at those retriever spans, I could go ahead and add those on top. And you can see just those ones there. So it's a really cool feature, and it's definitely one of our most popular, and we're going to get into a little bit of what happened after we initially released it, and all of the workflow steps that we go for this skill, but every other skill that we had. But before we do that, I think it's kind of cool to start like, okay, well, how did we get there with releasing that product that you all saw, that search? And so the first thing that we always do is we map out what we want this skill to do, how it should work. We showed you the high level architecture of all our routers and the skills and that responding to the users. Well, each of those skills has a little bit of its own architecture to it. And a lot of them look like this, where we're getting that input, it's going to come through its router. And then we have this data function. Each of our skills is built on top of the data that lives in Arise. So the first step in a skill like this is, well, we actually have to get that traces data to be able to do a search over. So you're seeing that in this block here. We're using GraphQL to get our data, and we'll grab the data and then do some data processing. So now I'm sending to Copilot just those inputs and some indexes. What's kind of interesting is we have IDs in our platform. So on the tabular side, you might have prediction IDs. LLM side, you have span IDs. If you ever looked at a span ID, it's a bunch of like a very long UUID. We actually decided to give Copilot just indexes that we convert back and forth. So what you're kind of seeing in this step here is I'm taking those span IDs, converting them to just, ordinal indexes that we'll send to Copilot. So we'll actually get a prompt formatted with that data, send that to the chat completion, and then we finally get that result that you just kind of saw on the UI.
Yeah, and maybe just to zoom out for like 1 second on this, Sally, if you can go back to the product, you could run through kind of some key themes here. So when we were starting off, simplest path first. What we just wanted to do was, here's a table below, the table that you see in the UI. Yep. So this table below just has kind of all the inputs, outputs of data the customers could send us. And when people want to search, they might want to search with natural language, and it might just want to be on, they just want to type out what they were searching for. So Sally did the whole, find me questions or inputs that have to do with ingestion. And we call this kind of column search. This is kind of the first skill because it only looks at one column. So it's not looking at across all of the rows. Um, it's not looking at all of the columns. Really, whatever the user types into that query, there's into that little search bar up there. What we're doing is just the function call is figuring out what is the column name that the user wants to search over. So that's kind of one of the parameters that's being extracted here inside of the function call. So in this case, perfect. So it's actually looking at find frustrated user inputs. In this case, it's kind of telling, our function call, hey, this is the column to search over. It's the input column. If you could just show that in the product, that'd be helpful, just so that people know there's an input column here. Yeah, right there. There's the input column if you zoom in to the table. So yeah. So that's kind of your input column. So it's not looking at anything else. It's just looking at data in that column, and then it's looking across all the rows to figure out, well, which of those questions have to do with ingestion related. So here, before we had multiple skills on this, it only had to pick one, which is the column search skill, and then it had to correctly extract what column in their data to look at. So the column was inputs in this case, and then it had to correctly figure out, like in this case, it was ingestion that Sally typed in. So what are the questions that have to do about specifically ingestion? And then once it does that, then it can translate that into actually how we query the data under the hood. So this is kind of the GraphQL query. But we had to do things like in this case, you know, finding data points that might contain certain words or certain, similar to, or doing similarity search. And so it's actually kind of finding all of these data points that look like that.
Yep. And I didn't mention it before, but well, as you were explaining that, Parna, it made me realize in like a router prompt, there's actually specific instruction there on the search router that says, okay, here's the schema and here's input. First step, you need to identify what column. And so that's actually how we first identify. And that's actually, as Aparna was mentioning, an input into this tool, column search. So we get the query, we get a specific column, and then that with the data that we pull from our data function goes into that final prompt that says, okay, here, your job is to identify rows with this criteria. Here's the column that you're searching over. Here's the data. Please return, search results in a structured response. That's another fun part of our system is we use a lot of structured output there, which is what you're seeing.
Yeah, and Daniel, your question in the chat's a great one. Again, how does the user get routed to the search router in the first place if there is no like mega router that handles? I feel like I just randomly made that term on this webinar. It's sticking. So if there's no mega router that handles the initial routing. So what we were saying, like Sally was explaining, it depends on where in the product experience they're coming from. So we know that they came from the search bar at the top, which is how we know we're going to route them to the search router. So that's how we are doing it currently based off a different, it's because Copilot's in different places in the product. Um, if you just show there's a search one, there's another one down there in the chat. So that's how we're picking the different routers. We have talked about, well, if we start to introduce more, yeah, there's another one here, which is evals, that has an entry point. So product entry points could be how you pick your router. We could also have a selection process where, we have a separate entry point that if it could go to multiple routers and there's no way to distinguish that from the product, we could do that. But I think what, like Sally was saying, we're going to probably get there. I think it's probably the next step here. And well, you guys will be the first to hear how that experience goes.
Totally. And so like, again, there's entry points in part of our application code kind of translate that. It's like I'm in the filter bar that equals search router, and that goes into what we call our planner that then selects, the routers. So that's how we like, set it up there. And so there's some questions about latency and how we cover that again, you know, the idea of going through all of the routers, because we take this software approach of saying that this entry point is equal to this router, we avoid that latency. And that's one of the main reasons we do that is like, there's no added latency. There's no added cost. We don't need an additional LLM call just to pick which router, because we already kind of have that opinion on which router should go with which part of the component. So that's one of the reasons. That's how we deal with latency and not increasing it when we don't need to. And I guess the other part of that is we also, of course, monitor all of that in our eyes.
Cool. Awesome. So now we got to the point of, okay, you guys heard how our MVP worked. We rolled it out. It was awesome. And then maybe you can go to the next slide, Sally. Oh, okay. Actually, we should cover this first. Yeah, maybe do you want to kick off? Okay, before we get into, the juicy part of well, what didn't work and what did we learn and how are we going to go fix that? Maybe we can just give you guys a view of how we think about the workflow of building and iterating on these skills. Sally, you want to kick us off on this?
Yeah, I think what we've really like experienced in building our own Copilot, our AI assistant, is like it isn't as binary of like prod and then dev. What we've really learned is it's very much iterative. It's kind of a flow where you're bouncing back and forth. And so this is kind of the workflow that we've outlined here, where you have a set of maybe production type workflows, but it kind of bleeds into the dev workflows, and they're very kind of related. And you could be in prod at one point, and then you're back in dev and back or back and yeah, you're in prod, then you're back in dev and back and forth. That's what we're really aiming to outline here. So we'll start here in prod. So just with AI search, we put that skill out into production. We're of course going to start tracing that code or that skill. And so we're going to have our traces in Arise. we're going to want to evaluate these. So, they're setting up things like guardrails for, external application, making sure that, we're not responding to inappropriate like inputs or not giving, toxic outputs, things like that. Then we're also going to set up things like, LLM as a judge for these continuous evaluations and monitoring on top of that. And so there's kind of this cycle of, you're evaluating and tracing your data. But what often happens is as you're, evaluating, monitoring, things come up. And we're gonna get into that with AI search of after production, what happened. And so what you start to see is you have this information coming from your evaluations that's kind of informing you to move back into this dev cycle. So what ends up happening is your production traces end up being your dev data sets. And that's what you're kind of seeing here is your evals and your traces are kind of being pulled into the dev, where you start to kind of iterate and evaluate and maybe make changes. Sometimes it's building new skills like we're going to talk about. Sometimes it's just improving on the performance of existing skills because you're seeing some edge cases that don't work right. So you're kind of going to bring these back into dev. You're going to collect and curate these data sets, and then you're going to start kind of moving along the cycle on this side of things where you're going to run experiments on templates or on specific evals. Oh, do you have something to add?
Oh, even models. I mean,
Yeah,
it's
model,
there,
anything.
but
Yeah.
I mean, you've done a ton where you've switched from,
Mhm.
4 to 4.0 and seen some things break. And
Yeah.
I think that, I mean, the key thing, if you take nothing else away from this slide, is just that, um, especially in building AI applications, the prod data is super valuable, and that data ends up becoming the data you use to improve the application. So that prod data is used as dev data sets.
Yep.
And you use that data to then go and you might say, okay, well, I'm not training a model. Like, what am I, this is an LLM application. Like, what am I using those data sets for? Well, using those data sets to do things like, few shot prompt optimization. You're using it to actually help you, test on certain examples that you may not have done well in production. Maybe the application responded poorly. Well, now I want to test, almost like unit tests. I want to make sure that my updated template or my updated, I swapped out the model and it still works on
Mhm.
these example points. And so you iterate on it, you evaluate those changes, and then the best of the best, kind of make it back to prod. You kind of ship the best. Um, and I think what you'll see is just this is a continuous iterative loop of you have your traces, your data from production, that data is continuously getting evaluated, that data gets pulled back into dev, and you use that data to build.
Yep.
Um, yep.
And we're going to kind of walk through, like with AI search, go through the whole flow and kind of point out like how we navigate this. And we're talking about one skill here. We do this for every single one of the ones you saw on that initial architecture diagram of, creating these data sets, running experiments, iterating, deploying, and then begin back at the top again. For anything else you want to add here, Aparna, before we kind of dive into the exact flow?
No, let's jump in.
All right, cool. So we pushed AI search into production July at our conference at Observe. Immediately, we saw this was our most popular skill. So I was paying close attention to inquiries that we were getting around this skill and what kind of questions we were being asked. And what you're seeing in this visual here is I began to quickly notice there were a bunch of questions coming in that I knew Copilot in its current iteration could not answer. You're seeing there a question about just general schema information. This user wanted to do some kind of analysis, understand what top categories were in their inputs. This user was trying to actually have Copilot construct one of our structured queries for them. And so we really realized that there's a lot that folks were wanting to use AI search for that we couldn't support. And so that really got us thinking like, okay, we need AI search V2 and it needs to be more than just one type of search. So we started with the column and search. That was that current implementation that we started, and that was working well. We weren't seeing like too many faults with that skill, just that there were other inputs that the skill just couldn't handle. It wasn't designed to do more than that. So we realized we needed a table search. That was one of the first things that was very apparent to us. Users wanted to do a broader search. They wanted to search for things that are just like traces. They maybe didn't know which column the data was in, but they wanted to find traces that mentioned something. They also wanted to do something like the example here where find traces that are hallucinated, but also mention the SDK. So that might be something that's across an eval and the input. So this was the second skill that we identified that we needed. The third was text to filter. I want you to turn my text into an attribute filter. I don't want to think about having to write my own structured filters, just do it for me. This was definitely one of the more popular ones that we got. I think everybody, when they saw AI search at first, this is what they assumed it did. They didn't think it actually did any semantic searches. They just assumed it would translate filters. So we definitely knew in the next iteration we needed that. And then lastly, analysis. And this one's really cool because what we really just found with this is it's kind of like this pattern of, categorize my inputs or categorize this dimension of my data. But it's actually kind of this precursor to filtering of, I want to segment my data and I want to filter, but I maybe don't know where to start. Well, the analysis feature would help them do that. And so these are the skills that we identified to go build. Anything to add to that, Aparna, before we get into how we did it?
I mean, I think only thing is just we wouldn't have been able to find this out if we hadn't just like dug through
Mm.
the production data. So we were looking at the types of questions that people were asking, and we realized, okay, people were asking questions that required us to look across multiple columns. So that was a limitation. They wanted us to um, you know, do some analysis. And so as we started to group together, kind of, okay, well, these are all questions we're not doing well in and we're failing. And originally you're like, well, that's not the point of this skill. That's maybe it's a user error. But I think as we're starting to see that these data points, we were like, well, these could actually just be additional skills.
Yeah.
And th this might be one to highlight on because I think we don't we don't talk about this enough is how do you know what the boundary between one skill and another skill is? Like why not try to force the table search, for example, and just expand your column search? Like why did you decide to break it out into multiple skills?
Yeah, it's a really good question. I think what we've really found through our development of Copilot is um, giving it one thing to focus on at a time is much better. We've had in like the early phases skills where we try to leave it a little bit vague of like if you think it's this, do this, and then if you think it's this, do this. And having the LLM have to kind of decipher through all of these guidelines and all of these tasks and then pick and then actually implement, it struggles much more than if you just say, okay, here's your sole task, the one thing that is your job. It performs a lot better. And then how we actually get those guidelines, this one's a little bit hard. I think there's an argument that we probably could have made the column search and table search work together, but I always just think about it as like if I was to give a person a task to do, would I consider that one task or two different tasks? And that's kind of how I actually think about it when I'm building these skills. Is if I was going to, tell somebody to reach out to a person and then, schedule a call, like that would be two. I wouldn't kind of like try to make them do it all, within one thing. So that's how I kind of think about it and how we determine what the boundaries are there of is it two separate tasks or one, or are we asking the LLM to attend to too many pieces of information?
Yeah. I think it's one where actually as you're probably building your own applications, you're gonna have to test that
Yeah.
and see what is the boundary of
Mhm.
how much can you shove into one skill and how well can it parse out what it needs. I think especially as the input parameters start to change, like for example, for table search, you're gonna need multiple columns and you're gonna need to be able to detect what are the multiple columns that are passed in. I think as you start to do that, that's maybe a little hint for when it might make sense to just break it out into a separate skill.
Yeah, and
Um,
experiments are a great thing to use that for. We've definitely used that ourselves of like, should this be one or two? Let's mock up some inputs. Let's pass it in as one skill. Let's pass it in two, see which one performs better. So I think that's another great use case for that.
yeah. Do you want to take a second before we keep going down and just tackle some of the questions in chat? I see there's a lot. So, okay. Amy asked, well, how do you achieve customer data privacy and security? How do you separate out the customer data? Do you want to take that one, Sally?
Yeah. So I think there's, privacy and security, of course, is just like a really loaded topic. There's so many different angles. And I think we take different steps of it. So, one, I guess in general, we chose Azure and OpenAI to build this with because of the built-in security and privacy. So I think there's that. And then we actually don't separate our customer data in our traces. So I'm able to kind of slice by different customers if I want to take a look at a specific customer's use case. And so that's kind of how we keep it separate. They're separate traces. Copilot can't be used across different spaces or different account organizations. But when it comes to actually looking at the data, there's no real security or privacy concern there, because we have our own private space that nobody could get to. So that's kind of how we approach that. So there's the implementation, privacy and security, and then there's the actual just kind of like a data analysis on our side. Yeah.
Awesome. And then I think one more question is by Vicky Haley. Are you doing any simulations prior to going to production to have confidence in the established guardrails for high-risk use cases? Vicky, I think we'll actually get into some of that as we go through the next piece here, but yeah, the data sets that we're talking about here is actually the ones that we then run the experiments on to actually be able to test what the outputs are going to look like on those data sets. So we have some teams, and it's not just us who do this. We have users who actually create these, must, succeed kind of, these important critical use cases as like a data set and make sure that it passes all of those before they actually update or launch the change. Cool. Okay, let's keep going down.
Okay.
Awesome.
Other thing I was going to call out, part of when you were talking about before, and I think it's a really important point where you talked about that we had to kind of comb through our traces. And that is really an important part of all of these workflows. Is when we first started with Copilot, we didn't know exactly what to look for. And I think tools like AI search can help you build that opinion. But just going through your traces will ultimately allow you to have those strong opinions. Now, when we go into our platform, we know exactly how to slice our data. We know exactly the things we're looking for. But there is that kind of learning curve at the beginning. And I think this process that we're describing, we went through with AI search really helped us build intuition around our data. And I think that's a really important call out.
Cool. So in summary, okay, what did we need to change? If you go to the next slide, the big thing we needed to change was that the search router, we started off, it only had one kind of skill, the column search. We needed to add 3 more skills. And those 3 skills were the, ones that we just listed here, table search, element analysis, and text to filter. So we first needed to write the actual skills for it to be able to do that. And then we need to go and update our search router to know, okay, well, now we have these new skills. You got to pick, you're not picking 1 out of 1 anymore. You're picking 1 out of 4. So how do you know which one to pick and pick it correctly? So with that, maybe we can walk you through the workflow. So first off, this is the first step that Sally was mentioning, which is we needed to figure out the data sets to you know, we need to figure out the right data to use to build all this. So for each one of those, call it skills, you might have a data set that was built. So a data set for here's when people asked us questions that were across multiple columns in the table. That's your table search data set. Here's when people ask us questions to do analysis. That's my analysis questions data set. Could have one that's like text to filter. And so these all became data sets that we use to actually build those each skills. But then we also needed almost like this overall data set that had questions, that had all the different types of questions. And that one was actually going to be used to test the router because the router has to pick which of the 4, out of the 4 skills, which one to call. And so you needed one where it had all of those questions together and then test if the function calling actually picked the right skill.
And I think, a big part of that too, and what you're going to see here is there's the creation, but there's also like the curation as well. And that's what you're actually going to see me do here is when we had to create that mega data set to use for our router data set, I didn't have any outputs that actually called the right tool. So what you're actually seeing me use here is our edit functionality. And this is the way that I could create actually ground truth for my data, because I didn't have real ground truth. So it saved me time of not having to create a fake data set of fake inputs. I had those already. All I needed to do was update the correct outputs. And so you see me do that here. So we've gathered all of the examples of queries we didn't support, and now we've actually updated them so that they have outputs that we can compare when we get to the kind of experimentation piece of things. Anything you want to add there, Parna?
No, I think we hit the key point here, which is we needed to build the data. Next, we need to actually go and update the router call. You want to jump to the next slide? Awesome. So we need to update the router. This is the iteration step. So maybe you can jump into actually how you define the task here, Sally.
Totally. Yeah, so with an experiment, you're going to have a few different components. We just talked about the data set. The second part is a task. And so a task is going to be any function or process that basically produces this JSON serializable output in our world. And this really, when you get down to it, this is aiming to replicate whatever part of the LLM functionality you want to test. So in this example, we're trying to focus on the router and we want to see if it's the correct function call. You might have other parts of this, like when we get to actually testing the tasks, where you might want to test, end to end. You might just want to isolate, that one skill. So this task can really be anything that any component that you want to test, you're going to set up your test to mimic that. And so yeah, here you can see I'm just doing a chat completions, very similar to what we do in Copilot's real code, grabbing, that tool response. You're seeing me format it so it's a little bit one-to-one with what we see in my ground truth, kind of an optional task there. And then we're just going to get that formatted response back, which will bring us to our next part, which is like, okay, we actually have to evaluate our experiments here. And so when it comes to evaluating an experiment, we need evaluators. And so there's a few different ways that you can do it evaluators. We have, LLM-based evaluators, we have code-based. We've chosen to go LLM in this example here, but this is just an evaluator to evaluate the correctness. I'm sorry, this is the wrong one. I think I have them backwards here. Nope, we duplicated the screenshot here. So this one actually would be the router here. And what we're basically saying is this is going to measure the success of our experiment. You can have multiple of them. And this is just saying, here is the function output from my task. Here is the function output from my golden data set that I created. I want you to compare and say whether or not they are the same, or whether or not the task essentially with the new router has selected the right function. That's at the router level. We also, in practice, evaluate whether the arguments that the router picked out are correct as well, to test both of those for the router is, can you correctly pick the right function, and can you correctly pick the right arguments? So when we actually did this, we had 2 evals associated with that. Then you also want to evaluate the individual skills. So I had to test that my router could actually call the skills correctly, but now I had 3 no skills, and I need to make sure that they actually produced good outputs. And that's where this second evaluator that we're showing here comes into play, where we're actually evaluating the correctness of the filter constructed by a tool, the text to filter tool specifically. So you can imagine each of these for column search, for table search, for analysis. This is just one example here. So it's kind of that twofold part for this change that we're making. One, router; second, skills. I see some questions coming in. We've got some questions about prompting. I'm going to save that one to the end if we have time, because I know we're running a little bit low, but we could spend honestly probably a whole session on prompting. We definitely learned a lot. I do get into it a little bit into a blog we wrote about lessons learned that we can drop, and kind of explain that a little bit in more detail. Oh, I see a question about, if a user prompt requires multiple functions and skills to be used, how does your agent handle planning and step-by-step execution? This is going to tie back a little bit to how you've set up your kind of LLM call. With OpenAI, for example, there are different settings you can pick, where it can pick, either a specific function, it can pick multiple. And as I mentioned before, our skills also have the ability to call different skills. So it depends a little bit on your specific setup. For us, the agent is able to pick multiple skills and it will execute them sequentially from there. And then it can also have skills that call other skills as well. Cool. Anything you want to add here, Aparna, on like our setup for like our evaluators or anything you would call out on those?
I think the key one is just in the data set, you typically want a ground truth or an expected kind of what
Mhm.
is the column that you actually want the output to be. So in this case, as we were getting input questions from users and that was forming our data set, we also had kind of a what is the right, if once it did the function call, what would the right function call be? And so when you're doing these types of evaluations, you can then check, well, did what the output from the tool call um, actually match the expected one that I'm hoping. And so this is probably one of the most important evaluations that we recommend you do for agents, which is evaluating if it called the right function. I think if it doesn't do this, if you don't have a way to evaluate this, you're just the product experience is just gonna call something you didn't expect.
Yeah. And we can in that this is just one example of us adding new functions, but you talked about like the model example before. And like that's another one. If you don't have kind of this setup, you can end up releasing, a bunch of broken changes that you have no idea are changing till after the fact. So it's just really helpful to get ahead of this and feel confident once you put something in production that your users are going to have a good experience.
Yeah. And maybe you can just jump and just show the experiment results actually.
Yeah.
Uh,
And we can go to the UI even to see this. But what you're seeing here is, once we post results back to Arise, you're able to visualize them. What you're seeing here, I had 3 experiments that I ran. I was kind of seeing things change over time. I wanted to actually drill into these experiment runs to see if I can identify what was fixed and maybe what's left to be fixed. Something that's really cool in comparison is you can actually add filters. So what I'm doing here is I want to see an experiment run 1 where the function selection was correct, but when I reran the experiment with a new set of changes, it became incorrect. So I'm kind of drilling in there to see, and that's ultimately what I would fix in further iterations here. So this UI is just really great for understanding how your experiments are changing and then being able to target exactly what's needs to continue to be changed or if there are any additional issues that you weren't aware of. So we have all of that data set data as well as the results from any experiments for you to use and some visualizations to help you as well.
yeah. Awesome. So I think the key thing as you see this is, okay, defined an experiment, what we wanted to change, how we wanted to evaluate it, and then we went ahead and kept track of all these different experiments. So each one of these are different prompt templates or different prompt templates, iterations of the router.
Yep. And you
Go.
can imagine different ones for, each of those other functions. We're just showing you router ones, but we have the same exact setup for all those other functions.
Awesome. And then if you see, there's the evals there, which is the evals are evaluating, well, did it call the right function? And then did it get the right arguments? And so those are kind of the 2 evals that we picked to quickly iterate on this.
Yep.
Um, awesome. And this is kind of just a fun one to say. Once, once it was actually, we kind of got to the spot where we were okay with the results. We deployed the change, shipped it, and and then I think this actually hits on Amy's question, which is, well, do you evaluate it in production? Absolutely. We were collecting all the traces and we can continuously kind of evaluate the application in production. Um, Amy, typically, I think your question's like, well, when is it appropriate to do it before returning to the user? In our case, we were doing the evaluation after. So we did the response, then we evaluated after. But in some cases, like more sensitive or high risk type of applications, it could make sense to actually these are typically called more guardrails where you actually evaluate the quality of the output and then you can even decide, well, do you want to show that output or do you want to block it? Do you want to retry for another message or another response? So typically those are slightly more kind of guardrails, and you can set up different evaluation approaches for how to evaluate the quality before you decide what to do.
Go
Cool.
into the takeaways. Should we quickly go into the platform and see the current state of?
Yes, go for it. Yeah, go for it.
All right, so I showed you the drop down and nothing's changed. I just was purposely not triggering any of our other skills. But now if you come to our platform today, those 4 skills that we discussed are all available. You can trigger the text to filter by using filter by, or just continue using natural language. I think one that I really enjoy using, especially for Copilot, is the analysis. And that is really powerful for building that intuition that I was talking about earlier. So if I wanted to ask, what are the 3 types of inputs I get, Copilot will take in all of that input data and it will begin analyzing and kind of clustering to understand what are the 3 types of inputs that this application gets. So it's going to look through over that data. And it's saying here, okay, this one actually is going to look at input and span kind fields. We're getting inputs or embedding type of inputs, retriever, queries. So this is just kind of giving us some ideas of what the different types of inputs we get, but this is where things get really cool. This is actually telling me now I can go ahead and filter off of these types of suggestions, and this will actually create either a structured query or an AI search query for you. So again, it really builds that intuition by looking over your data and saying, okay, maybe these are some things you should care about, and then providing you with the exact inputs to the next filter step where you can actually apply those and continue on with your analysis. So super exciting to have in the platform. If you haven't tried it out, I definitely recommend it. Cool. I guess we have a few minutes left. Let's chat takeaways.
Awesome. I mean, I think the big one, which you've kind of seen us go through, is it's an iterative process as we were building this. There's an MVP we rolled out. We saw that some things could have been better. We saw there were types of questions that people were asking, and we kind of went back into development and we used the prod data to pull us back and use it to improve. And so I think that's kind of one big takeaway here is there's a workflow and an approach of how to kind of keep iterating on this, and that's using the prod data back, using it to run experiments and then push them out back into production. So that's if you get one big takeaway from it, that might be it.
I agree.
Awesome. Well, I know that this is a long one, so thanks everyone for all the questions too. If you're using Arise, definitely would recommend checking out AI search now that you know a little bit of the history behind it. And then yeah, if you have any other questions or you want to hear more of our own build process, definitely join the next set of, kind of the next set in the series here. We're going through other agent applications in the wild, not just our own, but from users and things that you probably already use today, and hearing a little bit of insights along the way of how they built it. So awesome. Thank you so much, Sally. And thank you so much, everyone, for joining. Thanks, y'all.